literally at this size. Actually, even better. All right, Michael, you're doing this cool sphere picture. Where's the shadow coming from? Okay, I'll just do it. It's okay. No, I got you up there. Let's say, oh, I want to do this really cool thing. Maybe I have the light doing this, and a lot of my sphere is in shadow. And okay. Oh, and maybe I have, you know, the room is like this. Oh, actually, I don't want to put it that close because that will screw up my light. So I'll do it like this. Okay. Oh, but that's boring. So I'm gonna do this. You see what I mean? So do a thumbnail. Sketch out what you want. You know, draw something like this and say, oh, okay, well, oh, I know, I'll do it like this. And I'll have the dramatic low-level light. And the light will be like right there. And then if I want to put a corner in, I'll put a dead center. Because John hates tangents. And then I'll crop it real tight to make the effect dramatic. Okay, that's what I'm going to do. So that's the first thing I want you to do. Don't, remember what we talked about before, don't let the perspective tell you what to do. Figure out what you want and figure out the perspective that makes it true. Okay? So now, if we do something like that, you know, then we go to do your mechanical. The first thing I want you to do is I want you to draw a box, a perfect cube. I want you to use that construction technique I showed you. To find the center of the sphere, find the touch points. And using those three lines, you could draw three ellipses. And you know, you see what I mean? Those are the planes that we were talking about. If I draw it more fully. You follow me? Now within one of those, draw a perfect ellipse. You really only need one. I showed you all three just because I thought it might make more sense. And sometimes one is more convenient than another, but for our purposes, this ought to be fine. Now, if you have a single ellipse and you have, well, you can take your compass and based upon that single ellipse. Now, you guys, this is where accuracy is important. Is if you're not quite accurate, some of you guys may find that when you go to draw your cylinders like this, like look at these. See how these touch points fall inside of this circumference? some of you guys may have one of them fall outside or two of them fall outside. Well, that's an inaccuracy problem. The theory's still good, it's you have to be a little more accurate with your tools. Okay, and how you draw the ellipses. But so, this is what I want you guys to do. For your mechanical, use your cube to create the sphere. So you really know exactly where it is in space. This is, if you're sketching, you don't really need to. Okay, you can just eyeball a circle and then figure it out from there. But if you're doing it mechanically, I want you to use the cube as the basis for it. Now this has one additional advantage, you guys, and this is huge. Watch this. And actually, let me darken up my cube just ever so slightly so you can sort of see it more clearly. You guys see the 4 Delilahs that make up the cube? All right? Now watch this, you guys. Oh wait, actually, let me move that down here again. Don't want to screw that up. All right, watch this, you guys. Everybody eyes up for a second. If you have the cube drawn in, you still have all the other stuff we talked about. You still have the tangents, you still have all these other tools, but you also have this. What?
You always twist around there.
Yeah. Now, why would this be important? Because you guys, the reason this is important is if I've got my touch point and I've got, okay, there's my major. And there's my minor. Do you see that if you have you see that if you have the shadow of a box and you put a sphere inside of it, the shadow of that sphere must also fall inside that box? You see what I mean? So it's like if you have a shadow of a box now, you have an additional boundary to help you envision more precisely where that ellipse is. Now, let me show you guys one last. Well, go ahead and take some notes, and then I'll show you one last thing. Essentially, what I just did can be summed up like this. Because you have a mechanical box drawn, find the shadow of your mechanical box, and that will constrain the shadow of your sphere. Do you have a question, Andrew? Or Joe?
Yeah,
Andrew today.
I forgot, how did you find the touch point? Oh, that's just the bottom.
Right, right. Yes.
So is the shadow of your cube the same thing as the bounding box then? It's just another way
Yes.
of finding it?
Oh, no, technically not, that's not quite right. Because what's happening here is my bounding box is a little bit more accurate, because imagine the boundary box going like this, and going like that.
Oh, okay.
So the boundary box will probably be inside the cube, but being able to see the shadow of the cube will help you visualize, oh, it's going that way. You see what I mean? And I just find it helps people kind of visualize, you know, if you've got something like this, and you're going, okay, well, there's a sphere floating in there. So, you know, if the shadow's doing this, well, then the sphere is gonna be floating in there too. Yeah.
Would you suggest, like, when we're doing the mechanicals of these, to do it in like layers of?
If that helps, absolutely, if that helps you, absolutely, especially this next thing I'm about to show you. Because it's starting to get complex. Oh, I gotta show you guys my notes real quick. It'll make you laugh. Hang on. I did this for fun for myself, and I looked at it and I thought, oh man, I should. I was debating if, okay, should I even show this to them because it might freak you out. Now, mind you guys, when I do some of the notes, like what I was doing last night, I drew them in Photoshop layers and then just kept doing new page, and turned off the previous pages. But there's my notes for this lecture.
Oh my gosh.
You know, it's like, yeah. You know, then I turn them off and I save them as separate JPEGs, but it's like, it looks ugly as hell. Yeah.
How did you determine the length of your minor axis?
I haven't yet.
Okay.
I haven't done that yet. The way, you know, you guys, what we haven't, you also have to do this mechanically. I forgot to do this, I'm sorry, but this is one additional step. One of the first things that you should do is draw the ellipse mechanically into the bottom face of that cube. Because that is your drip line. And that drip line is going to constrain everything really effectively. Here's the other thing that it does for you, though. Let me, well, is any questions before I get taken down another road? Yeah, Katerina.
I was wondering, how do you determine the ellipse on top? Do you use the half of the liner?
How do you determine the ellipse on the?
The first ellipse you determined was that using the radius is half of the major axis?
No, what I did for that was I would construct an ellipse using the square plane that goes through the center of the sphere. So if you visualize that, you know, if you visualize, if I have a cube, like this, I'm basically bisecting the sides and I'm drawing this plane that's going through the middle of the cube and then constructing an ellipse in there. That's how I find my circumference, yeah.
Do you want us to make that ellipse with the same method, like where you kind of project the square?
Right. With this ellipse, I would have to make that the way we did the mechanical ellipses for the cylinders.
So the like projected square and then
Using like a measuring points and, you know, like, yeah,
Okay.
exactly. Do it as precisely as you can. The more precisely you do it, the better your result, yeah.
How did you determine where to put the minor, like in terms of
Oh,
where it crosses the major?
I'll answer that in just 1 second. Here's something else you guys can do. If you guys actually draw the drip line first, you can take, to get the center ellipse, you can just go boom, and go straight up. It's the same ellipse. It's like making a half cylinder out of a sphere. You know. Now for the major right here, you mean?
Yeah.
What I did was I drew from the light source through the center until I hit the major, and then I drew a perpendicular line.
Okay.
Okay? All right, now. All right, you guys, so this part, pay attention, keep your eyes up. I'm gonna draw the form shadow. I would use that same method we talked about before to split the line at the midpoint. I draw the curvature from there to here, and it would end up with points like about here and about here. Again, I would do it mechanically. Now, okay, I'll just do it. That's a boundary line. That's a boundary line. Now notice that they cut they cut the corners off my cube shadow, which is exactly what should happen. You guys see that? The corners are what should get lost, okay? Now if I do the same thing for the radiation point, I'm gonna get a boundary box like this. Okay? Now, I'm gonna use a darker marker. I think you guys are understanding me okay up until now, and this next step I wanna try and do without having to redraw the entire diagram. Remember when we did the cylinders and you were trying to map the part of the cylinder shadow onto the wall or something, and you needed to use the little Delilah method? If I draw the ellipse, and I draw it accurately, oh, and this would be a pretty fat ellipse, I should say. This would be about this would be a good 45-degree ellipse, so let's go out to here, let's go down to here.
You just did that from knowledge?
Well, I did I used that ellipse trick before, like that's halfway, that's a 30-degree ellipse, that's a 45. And now, I'm looking at this radiation point, and I'm looking at how far in front of the sphere it is, and I'm guessing it's close to 45. Now, what you guys can do when you're doing it mechanically is you can look at the diagonals on the bottom of your square, and it will tell you, okay, there's the 90, there's the 45, there's the 0, and you can extrapolate really accurately based upon that base square. But you know, this is I'm shortcutting something right here, but that's basically how I would have you guys do it: is look at the angle that the light is coming into the bottom of your square, and see. You know, use that as the basis for your degree ellipse, or your ellipse degree. Yeah. All right, now you guys watch carefully, look at this. So I've got, see the two lines in black? What I want you to imagine is if you need to find any particular point on the shadow, watch what you can do. Here's a Delilah. Where is she? That point right there is right there. You see what I mean? And I can draw a bunch of different Delilahs if I wanted to. You follow me? And as long as you're connecting one to one, you should be able, you know. But ultimately what you're going to end up with God, this drawing is messy as hell. Now, just want you guys to imagine. Imagine if we'd started there. Do you see why, I mean, we just spent an entire class, you know, doing this one little thing, but do you see why I broke it down the way that I did? Because every individual step isn't that bad. But when you get into the final thing, that's insane. You know, and that's why mechanically you won't do this very often in your career. It's important that you guys know how it works. And again, you won't find this in any book that I know of, but that's how it works. Yeah.
Oh, okay, I think there was a step I didn't quite get, and it's how to find the terminator line, or the core shadow line. How to find that ellipse, how do you know what degree it is?
The way you know what degree it is, you have to guess based upon, let me show you. You have to, if you can envision the square, and then envision the angle at which the light is coming in. If it's coming in at this angle, it's a 0-degree ellipse. If it's coming in at this angle, dead on straight ahead of you, it's a 90-degree, it's a full circle. If it's coming in at a 45-degree angle, it's a 45-degree ellipse, 30-degree angle, it's a 30-degree ellipse.
Is there a mechanical way to find the, like, precise point without visualizing it? Or do you just have to?
This
sketch it?
is a mechanical method. I mean, that is accurate. You know, if I have the light coming in here, and it's coming in and hitting the center of it, you know, directly through there, that is a 15-degree ellipse. That's mechanical.
Is there a way you can show us how to do that on the sphere? Like, I mean, because it looked like you just kind of drew the core shadow line in.
I did.
And that's the problem I have. It's like I would have to actually see, like.
Okay, let me show you. I think this will work. I'm not certain. Yeah.
Quick question.
Yeah.
So that, are we looking down on it there, or
Yeah.
is that from the side?
Yes.
Okay. Thank
Yeah. So this next thing I do might help. Okay, imagine we did all the other stuff. Okay, so imagine we did all the other stuff, and imagine you know what you guys might do? This also might make it easier on you for your mechanical. Do your mechanical cube in one point, because that way the bottom square is oriented such that it's, you know, it's absolutely correct, because you're going to do it on the eye level. So go ahead and do your cube in one point, and it'll actually help you construct it, I think. Okay, you with me, Joe, you with me so far?
Yeah. So
Okay.
you have your square in one point on the bottom.
Right. Okay, so you guys, now picture this. I'm gonna draw an eye level over here, or I'm sorry, an eye level. I'm gonna draw a light source. And I'll put the light source up here, but I'm not telling you yet where it's in front of or behind. Now Joe, tell me where you want the light 3 different times. Okay, so I'm gonna go like this, and tell me when to stop.
Stop.
Okay, now if I stop there, everyone watch. If this is, all, I'm gonna say red 1, we're gonna do this 3 times. What angle is that? This is 0, this is 45, that's about halfway. So I'm gonna call it, let's call it a 20. You see what I mean? Okay, now Joe, one more time, keep your eye, oh, and I'm gonna say a plus 20, because it's in front. Now Joe, tell me when to stop.
Stop. Or yeah, a little higher.
Okay, let's go there.
Stop there.
Now the light's behind us, but now look, that's about 2/3 of the way to the 45 degrees, so I'm gonna call this one a -30. You follow me?
Yeah.
So now if I go to draw that, watch what happens. And again, imagining like my tangent lines. There's my major. Now you guys, if this is my major, watch carefully, and this is a -30, I'm gonna go halfway, gonna estimate it to about there, and then that's the arc. Because
So you
the
have to use-
light's behind.
You have to use the sort of like the ratio.
Right, the
So-
ratio trick,
okay.
exactly. And that's why that ratio, one of the reasons why that ratio trick is so powerful.
So you have to use one of those, or in order to be really fairly accurate, you'd have to use one of those ratios. Like one of the, like either the
Oh,
10.
No, you can, if you really wanted to, if you wanted to be hyper accurate, you could take a calculator and type in 22 degrees and hit sign and it would come up. You know, that would be the ratio. So, you could be super hyper accurate. I don't think it's really worth it because most people aren't gonna be able to tell the difference between a 20 and a 22 degree ellipse. You see what I mean? If you just estimate it, I think you're gonna be as close as anything.
So would you recommend that we, like choose where the top of the light source is and then maybe find the 2 points and then choose like how big we want our
You know,
ellipse to be and then find
What
the rad?
what I would do is I would sketch out what you want your sphere to look like
Mhm.
and then reverse engineer it that way.
Okay.
You can really, the true answer though, you can do it forward, backward, or sideways, doesn't really matter. You'll get, if you do it correctly, you'll get the right answer.
I was gonna say, well, I guess it's kind of his question. Oh, we'll do what we want, but you have the light source on the table at one point.
Yeah.
So the light source and the ground are like the same.
Hey, you guys, I just thought of something, and we're out of time, and so I apologize, we gotta wind up. But I wanna try one thing with you guys real quick. Come to the back table.
Hi, Nathan.
Excuse me, guys. So what I'm thinking, you guys, is just because we've done this now, I hear a racquetball. It might make more sense if we stop this. Does it help seeing it before and after like this? Does it change or is it no difference? Where's that racquetball? If you won't cooperate, you don't get to play. Notice how both major axes are pointing at me? At the light, I mean. Does that help at all? Does it change anything? Was it worth doing?